Rounding in multi-step calculations. We frequently have to do more than one operation to get our final answer. So we need to avoid rounding errors. When we round at each individual step, we can end up with sometimes significant errors in our final result. So what we want to do is not round until the final answer. Sometimes you can do all of the calculations on your calculator at once, just plug them all in and not have to write anything down. That's the best thing to do. Write down your final answer, then go back and figure out how do you need to round it for sig figs. If you do have to write down an intermediate value, make sure that you carry a minimum of 2 extra digits when you do that. And I will be following that pattern in all of my examples. If you carry 2 extra digits, you don't even have to worry about rounding the second one. If you just write down 2 extra digits and carry those through, you don't have all those crazy numbers, but you also won't have any rounding errors. So what do I mean by all of that? Here's an example of a problem that involves multiplication and subtraction. So when these two different operations are present, then we have to consider the impact of each of them separately. So do the math on your calculator and come up with 19.1707. But then we have to look at intermediate values to determine what we're going to end up with significant figures. So this is subtracting, and when we're subtracting, we're counting. What are we counting? Decimal places. So look at the value of this subtraction. The calculator says 0.479. This number has 3 decimal places. This one has 2 decimal places. So this result only has 2 decimal places. So the 7 is underlined to indicate that is the last significant figure. I'm going to keep the 9 there. I'm not going to round it off. But I just need to make myself aware this number has 2 sig figs. Then I have these other numbers that are being multiplied. Now I've got all of the same operation. I can multiply those and then count sig figs for the multiplication. So counting sig figs, this one has 3, this one has 4, this one only has 2. And so that tells me the answer needs to be rounded to 2 significant figures. You can't get that just by looking at the numbers you started with. None of them have 2 sig figs. You have to look at the subtracting step, counting decimal places, to identify how many sig figs are in the result of that. Questions? Do some examples. I'm going to skip the first one just because it's multiplying and dividing. You just have to count number of sig figs. If you want to see that one, I'll show it to you later. I am going to do B, even though it's all one group of operations, just because that one tends to be more confusing for students. So first, just do the math on your calculator. 0.881 plus 132.1 minus 12.02. And write down what it says. $120.961. Adding and subtracting use the same rule, so we can lump them together. Counting decimal places. So this number has 3 decimal places. This one has 1 decimal place, and this one has 2 decimal places. That means my answer is limited to 1 decimal place. I'm going to keep the 9 and get rid of the rest. So I underline the 9 to remind myself, okay, that's where I'm rounding. Then I look at the next digit, the decider. The decider says I have to round up. So I round the 9 up to a 10, which bumps this 0 up to a 1. And the answer is 121.0. I set out to keep 1 decimal place. I have to have 1 decimal place in my answer. Pointer. Okay. I have to have one decimal place. I can't just say 121. I need to say 121.0. Questions about that one? Okay, so these are the ones with mixed operations. So do these on your calculator. Order of operations does come up, okay? You need to learn how to communicate best with your calculator. If you're having issues, come and talk to me. So do this on your calculator and make sure that you come up with the same answer. So I'm getting 1.174270. Oops. Anybody else get that? You have to make sure you're dividing by the quantity of those together. Okay, so I've got multiplication, division, and addition. So I need to look at this sum and look at the intermediate value so that I can figure out how many sig figs that has. So the 44.11 plus 1.223. So I look at that, and that would be 45.333. That's what my calculator tells me. I apply the rules for adding, subtracting, counting decimal places. So this one has 2 decimal places, this is 3. 2 is the smaller one, so this number would be rounded to 2 decimal places. Doesn't matter how many sig figs it has, 2 decimal places. I underline the last significant figure so that when I'm looking at the multiplication, this times this and then divided by this, I can see how many sig figs this would have. This number has 4 significant figures. This one has 4, and this one has 5. So I'm going to round my answer to 4 significant figures. 1.174. Any questions? Most students are not going to understand this the first time they've heard it explained. And maybe not the 100th time. If it's not making sense to you, keep asking questions. If you keep asking and keep trying, it will click. Once it clicks, piece of cake, you're like, oh, that was easy. Yeah, but until it clicks, it's just horrible, right? Keep working at it. You can get it. You got this far in school. You can get this. Just keep asking me about it. Okay, so here we got this one. So again, do the math. Calculator says 8.414. Oh, that's awfully messy. Did I do my math right? Okay. We got multiplication and we've got adding. So let's look at the multiplication and what that result is. 12.01 times 0.3. So that is 3.603. And I've got 4 sig figs and 1. So this answer, if that was my final answer, could only have 1 significant figure. Well, that's disturbing sometimes. People are like, I don't want to round it off that much. Sorry. I need to identify that because now I'm going to add, and so I have to count decimal places. This one is in the ones place. It's actually 0 decimal places, right? And this one has 3 decimal places. So I'm going to round it to the ones place. I'm going to round this here, and I'm going to say this is 8. when you do calculations, and maybe most of your numbers are pretty precise, you've got a lot of information, and one of them is not very precise, it's very approximate, that makes your whole answer approximate. Okay. Any questions?
Yes.
Mm-hmm.
For letter C,
Mm-hmm.
the underline, when we add the 44.11 plus 1.223,
Yeah.
it's became 45.333. Then we underline the hundredths, but then our answer, 1.174,
Mm-hmm.
we underline the 4 on the thousandths.
Yeah.
So
Why?
why is that?
Okay, so the question is, I'm repeating it for the YouTube people. The question is, here we've got the hundredths place, but then in our final answer we have the thousandths place. How does that happen? Right? Okay, so this is the hundredths place because we're looking at addition, we're counting decimal places. So now we've got this result, and it has 4 significant figures. We're dividing and multiplying now, so we're looking at number of sig figs. We're not counting decimal places anymore. So this is 5 significant figures, 4 significant figures, 4 significant figures. So the answer has 4 significant figures. Okay? You have to puzzle through it a couple of times, and then hopefully you'll go, oh, okay, I see that now. The thing with adding and subtracting is you can end up with way more significant figures than you started with, or way fewer significant figures than any of the numbers you started with. It's really kind of tricky. Any other questions? Yeah.
So on letter D, is it necessary to put a decimal after the 8?
That's a good question. Do we need to put a decimal point after the 8? No, we don't. This 8, what's kind of sloppy about this example is these really should have units on them. Because these are intended to be some sort of measurements. And so if this ended up, being meters or something, that unit would tell us, oh, this is a measurement. This isn't an exact number. If we do just have that number 8 sitting there, is that 8 people? That would be exacts. So that could be a little confusing. The only time you need to put a decimal place is if you have trailing zeros that are significant. Maybe you end up with the number 10, and this 0 is significant. You can indicate that with a decimal point and write it this way. That's not ideal. It'd be better to put it in scientific notation. But you do not have to put a decimal point for that. Any other questions? We talk about accuracy and precision in chemistry. Accuracy is how close the value is to the true value, how close your measurement is to being the right number. Precision is how consistent you are in making that measurement. So, how reproducible your measurements are. Accuracy and precision do not always go together. Sometimes we use a target. Think of a dartboard. And you could have several results that are very precise. So I'll make red X's. So I'm throwing my darts or shooting my arrows, and they're ending up over here. I'm very precise, but I'm off the mark, right? So I am not very accurate. I'm really good at getting my darts close together. I'm consistent in where I'm shooting them, but I can't hit the bullseye. So this is precise but not accurate. We often make a bunch of measurements and then average them. And so I would look at the average value. So let's say I'll make some blue X's. So now my darts are like kind of all over, around the bullseye, but none of them is hitting the bullseye. But if I average those results, the average might be in the bullseye. So the average result would be accurate, but the precision is poor. So let's look at 3 students weighing a lead block. So we know that the true mass of this block is 10.00 grams. They're each weighing it 4 times and reporting an average. So let's look at their average first. 10.13, 9.79, 10.01. So who is close to the true value? Student C. 10.01 is very close to the correct value. So this student is accurate. This one's low, that one's high. Not very accurate. To look at precision, we look at how close the numbers are to each other. It's a little bit hard to see in this table of numbers. So that's why we use graphs, is to take points like that and make them visual. So here, same information presented in graphs. So here, each of these purple bars represents an individual measurement. The blue is the true value. The dotted red line is the average. So we see student C, the average, very close to the true value, accurate. We see that these purple bars, each of these measurements is similar in height. They're close together, so this is also precise. If we look at student B's average was low compared to the true value, not precise. I'm sorry, not accurate. But these results are very consistent. All of the values are close together. It's precise. So you can be precise and not accurate. And then there's student A. Inaccurate and imprecise. Results are all over the place, and the average is off. We would like to be like this student. This is not always possible, but that's what we're shooting for. Any questions? There are 2 kinds of error. There's random error and systematic error. Random error, as its name suggests, is random. Sometimes it's high, sometimes it's low. And so we can eliminate random error by averaging multiple results, because sometimes the error will be high, sometimes low. So you make a whole bunch of answers, average them, and the highs and the lows average out. And get rid of random error. Systematic error is always in the same direction. It's always high or it's always low. So student C has little error, either random or systematic. Student B doesn't have very much random error, but he has systematic error. Systematic error can be caused by a number of things. Probably most frequently is it's error on the part of the person doing the measurement. You're misreading the burette, or you're using the balance improperly. It can also be caused by an improperly calibrated instrument, or something odd, like, there was an extra piece of paper on the balance that you didn't notice or something. It's like somebody putting their thumb on the balance and always pushing on it. Well, it's going to be off every time, right? So there's multiple sources of systematic error. Any questions?